Assalamualaikum and very good day. My name is Faizal Zombie alias. My ID number is SEA17001. So my assignment microprocessor for BEE 2223. The title of project is UART Programming Display, and the lecturer by Cik Badruddin bin Muhammad. The project assignment brief. The project basic design is to provide an output display which show the output data of alphanumeric and special characteristic on virtual terminal or LCD screen in Proteus by using microprocessor STM32F103 ARM Cortex M3. In order to achieve the project objective, hence they are required a fundamental of assembly coding program in Microvision and approach with Proteus CAD software towards to accomplish the project successfully. These adhere with outcome learning for subject microprocessor BE 2223. The synopsis project. Student able to generate and output data consists of alphanumeric and special characteristics on virtual terminal of LCD screen in Proteus by using microprocessor STM32F103 ARM Cortex M3. The basic material required. First, about the hardware. Of course, we are required or we are need the microprocessor STM32F103 ARM Cortex M3. We also use LCD digital display if required. We also need USART or UART. We also need DC power supply and ground terminal. B, we also need the software. So the student must have installation Microvision 5 and also the student must have the software Proteus 8 CAD connected. This slide to show about the block diagram. Basically, our block diagram is consists of two elements. First is in input and second is output. So for the input, we are in need the data assembly, which is we need to record and write all the code programming in the kill in the Microvision software. And for the output, we have look the virtual terminal output or LCD terminal at the Proteus software. And we also need the power supply as input, and nevertheless we also require microprocessor STM32F103 6C. This is about the flowchart of this project assignment. First, we need to enter the data into the kill code programming software. After we enter this data, we have to initialize the clock for GPIO. To set the clock to initialize the clock for GPIO, the command is shown as below. RCC APB 2ENR, RCC APB 1ENR. And after done initialize the clock for GPIO, we have the configuration for the port GPIO. For this project assignment, GPIO CRL, and after done that one, we have to read the data. After completely read the data, and then we'll show to the display output in the virtual terminal for UART program display. Then end, and then we'll go back to entry. At this slide, we would like to show about the kill code program. So the kill code program in the kill microvision is shown as above. Okay, this is I would like to share and show you about the key code program. So for before we get the output, we have to rewrite all the particular detail, all the coding program. So what we should declare, we should also make sure the clock has been reset, GPIO and USART2, and then we have to put the data. So what characteristic we put is the output is stay safe, and the characteristic is fight COVID-19 hashtag. So we also need to put the data here while for delay for in int I equals 0, and then USART2 underscore write and delay ms50, and then void USART2 write int.ch, and then after we complete everything, so we have to build this code program before we run the system. So from here we can see no error and zero warning. So that means our coding program is good. So the next one, after we done the key code program and we build this file, build F7. So please double check again. Is make sure it's zero error and zero warning. So that means the hexa file has been created. So after we did this build target for target 1, so we have to debug the system by click this cursor, start and stop debug. So you just click this one. And after you click, we will show like this. So let's pop up one Microvision box here. It says evaluation mode running with code size limit 32K. So you just click it on OK. So this is the image or the screen after you run the debug. So from here you can organize the windows how it look like. So I'm select like this condition. So from here you can see the startup for STM32F10X. So the data is something like this. So you see the copyright 2011 microelectronic version. They also have a EQU space. Have DCD reset handler. They also have external interrupt. And then for after you see this thing, you can see also this system, the coding. So you can run the system. Just press this button, step in bracket F11. You can see register 0, change the value, the address, the data address, and also the memory address. You click again. Then we go to RCC. And after click again, they will go for the next instruction, RCC CR, and then we go register 15 PC, and they got this address email, this address data.